Okay, everybody. Hello. Here we are with uh, the next class. I believe this is week 5 of Introduction to Qualitative and Quantitative um, Research Design, and I have given back your initial versions of the annotated bibliographies. Um, and you should have everything graded by now. I do apologize. I was a little bit behind on grading. I realized I hadn't gotten back the research list to you, but they both have been graded, so you should have everything back at this point. I do want you to remember that on Thursday, there is you're supposed to turn in the revised version of your annotated bibliography, and that is, uh, you just would apply the changes that I gave you to your, um, just follow along with the feedback that I gave you on your annotated bibliographies, the one that I gave back. Uh, for the most part, they were very good. No, for the most part, they were very good. The only thing I would want you to keep in mind, this was the case for all of yours, was that um, when the one thing I know that I would like you to address in all the articles that you review is I would like you to get some sort of sense of what the articles tell you about how research in the area that interests you is conducted. Because I'd like to start reviewing articles to get an idea of what you might be able to do with your own research proposal. Because I think that's going to be very important for for uh, what you um, for moving forward with your own proposal. And because if you can get an idea of how other researchers did their research by looking at their articles, that should give you some idea about how you might be able to do your research. And I think that will be something that you want to do with every article that you review. Also, please keep in mind that in your literature review, using books is fine, but I would want you to give particular attention to using articles. That's what I really want you to focus on because the articles are what are the articles are what are going to show you how the research was done, and I think that is essential for your proposal, having an idea of how our research was conducted in your uh, in the articles you review. So, okay, just to give you, by the way, just to start off with this lecture today, I want to just give you a sense of how um, I want to give you a sense of how a research proposal should look, what you need to have in your research proposal. Keep in mind that what you want in a proposal is a summary of the main parts of what you plan to address in your research study. So you want to start off with the introduction. The introduction is going to summarize the research um, that relates to your topic. So when we've talked about the literature review, that is going to make up the bulk of your introduction section. And then after your introduction section, or at the end of your introduction section, you want to have the research question that you're asking, and the hypothesis is if it's a quantitative research study, and if it is a qualitative research study, you want to address what what sort of general issues you will be looking at in your study. Maybe a start of what sort of themes you think will come up in your qualitative research study. And then after you um, build on your um, hypothesis, and then your research question, then your hypothesis, your research proposal, when you eventually do the final version, will have a method section. In the method section, you will talk not only about um, what uh, how you plan to collect the data, but you will also talk about what sort of instruments you will use. Keeping in mind that if what you are doing in your study involves, um, if what you are doing in your research study involves um, instruments that have already been validated and developed, then you will want to talk about the validation research, that the validation and reliability research that is already out there on your on your instruments, on the instruments that you plan to use. If what you plan to use um, uh, is a survey, if you plan to develop your own survey, then what you will want to do is uh, in your method section, you will want to describe what sort of questions will be in your survey. And so you want to not only talk about the questions that you plan to use, but the research evidence that you have for why those questions are valid. Um, okay, why there is research, why you have empirical evidence to support that those questions would indeed be valid questions to ask. Okay, so what you want to do after you have the method section, where you, as I said, where you summarize information about the instrument that you plan to use, or where you outline what you expect to be the questions that you will have on the survey. And if you are doing a qualitative research study where you have a survey, you want to not only summarize the questions that you plan to use, but you want to outline what the research evidence that you have for using those questions, what you feel or what you find in the research that best supports your using the survey questions that you plan to use. So those are the those are the steps of the method section. And then after you have the method section, um, you then want to go on to the results section. Now, the results section, of course, you won't have actual results because it's a proposal. But what you want to do with the results section is to summarize what sort of statistical tests you will be running, if it's a quantitative research study, or how you plan to analyze the surveys if you are doing a qualitative research study. And then in your description of the discussion section, you will talk about what you expect to be the means that you will use to interpret the results of your study, and how you plan to address where your results fit in with the results that have been found throughout research on your topic. So you will have the introduction section, which will include your literature, your hypothesis, your literature review, your research question, your hypothesis, or the general themes that you expect that you might find. If it's a qualitative research hypothesis, if it's a quantitative research, your method section, which will outline uh, the procedure you plan to use to collect your data, and the instruments that you plan to use. It will also address your survey questions and to um, what you plan to ask and what research support you have for asking the questions you plan to be on your survey. And then you will get into the results section where for a proposal, we'll talk about the statistics that you plan to use for a quantitative research study and the analytic procedures that you plan to use for a qualitative research study. And then in your discussion, you will plan on how you expect that you will address um, where your research findings fit in with um, the research as a whole. Okay, so that's moving forward with your research proposal. Of course, your research proposal is the final project that you will have, but you really want to make sure that by this class you have the research question that you plan to use, um, and the general research approach you plan to take for your study, or at least have an idea of whether you want to be quantitative or qualitative. Okay. Um, Now, as you see on the syllabus, the topic for this week is going to be descriptive statistics. So I'm going to talk about that some in this video lecture. So um, let's review though, and I know you have the text, but let's review. So in a quantitative research study, what are you doing? You are collecting data on a sample of a um, population. So, in order to keep in mind that with a quantitative research study, when you are using statistics, what you are doing is you are collecting data from a sample. And what you want that sample to do is be a representation of a population. So, for instance, if you wanted to study the effect of testing or the effect of um, uh, what year someone is in, as far as what college year they are in. If you want to test that effect on test anxiety in college students, you would gather a sample of college students because you certainly can't test every college student on the planet. So you would gather a representation of that population. Now, what you would try to do is um, you would try to do is have a sample that, in as many ways as you can, mirrors the way the population looks. So, for instance, even with um, if you were doing a test on college students, you would want your sample, and I don't have the exact number of this, but I expect you would want your sample to have an average range in the early 20s, because the average range of the average range of college students is in the early 20s, even though there is a larger population than there used to be. of people going into college in their 30s, 40s, and 50s, um, the average age is still in the low 20s. The majority of students who are in college still tend to be those who went into college right after high school, right after, immediately after high school, or shortly after graduating high school. So you would expect the average age to be in the low to mid 20s. If you were, if you had a sample of, uh, if you had a sample of college students and the average age of your college sample was 48, then you probably would not be able to say that your sample mirrors the population. You may be able to say that your sample mirrors that group that is known as non-traditional college students. Non-traditional meaning that that they have gone back to school, they've gone back to college years after graduating high school, as opposed to immediately or shortly after graduating high school. So very often you use um, descriptive statistics, and that's what we're leading into. You use descriptive statistics to describe your sample. And part of the reason you use descriptive statistics to describe your sample um, is so you can show whether or not it mirrors the population that you are looking at. So, if you have a population and it turns out that it's 95% female, unless you were specifically studying um, uh, that you were specifically studying females, uh, that probably skews too far in one direction. So it would show that there is a limitation in your sample in that one group is represented more than that group is typically represented in the overall population. Now, it doesn't mean you couldn't say, well, then we're going to just make this a study of females as opposed to uh, uh, being of the general population. That would be fine. But usually you would use descriptive statistics to identify whether or not your sample reflects the population. So we're going to talk about descriptive statistics. Um, it is used for more than just saying that if your sample is reflective of the population. It's used for more than that. I bring that up because it's one very important reason for using descriptive statistics, because you ultimately want your sample to be as close as you can to being a snapshot, a mirror, a reflection of the population. You want to be able to say that as much as you possibly can, um, because that is going to direct how much of a conclusion you can draw when you get to the discussion section. Because remember, if you are studying, again, the effect of year in college on test anxiety, with the hypothesis, as I brought up in an earlier example, with the hypothesis being that um, first year students have higher test anxiety than fourth year students. Um, if you are going to do that, as I said, you are not your sample size is not going to be, you know 25 million or however many college students there are in the world. Your sample size would be, let's say, 200. So, but when you um, when you gather results, you do not want your results to would be ones that you can just say, well, this tells us about this group of 200. You want to be able to draw conclusions about the millions of college students out there. So the general thinking is, if you have a sample that mirrors the population in terms of age, uh, gender makeup, percentage of gender, um, socioeconomic status, geographical location, the more evidence that you have that your descriptive statistics mirror the descriptive statistics you would expect to find of the whole population, then the stronger your conclusions are when at the end you say, okay, this is what our study tells us about the population. So this is what we can draw conclusions from this study that apply to the whole population of college students. So that's typically what is seen as what you do for quantitative research. Qualitative is different. You still use statistics often in qualitative research to describe your sample, your participants. Um, but usually it's much smaller. So in a qualitative research study, you may only have six participants. Well, if all you have are six participants, you can describe the makeup of those of that sample on terms of important demographic information, but just listing it for each of the six individuals. You don't have to have descriptive statistics. You could just list information. But with quantitative research in particular, you usually use descriptive statistics because you may have several dozen or even several hundred subjects, and you're not going to list all the demographic information for each one. You would usually rely on descriptive statistics to give a snapshot. But the general picture is descriptive statistics give you a snapshot of your sample. So they allow for readers of your study to get a good understanding of what to get a good understanding of what your sample looks like. So, um, and that is particularly important when you have when your sample makes up a large group of individuals. Okay, so what are some of the main descriptive statistics um, that we use? Well, the first one, uh, the, let's start with very often. Um, uh, the some of the more basic descriptive statistics um, help you. The main purposes of some of the more basic descriptive statistics are to either organize data or summarize data. Now, organizing data is actually, um, you might even argue, is not a statistic at all. It would be basically it's tables and graphs. So some uh, commonly used uh, methods of organizing data, and it's called descriptive statistics, but really it's just these are just specific methods of um, showing the results. One could be a frequency distribution, which is just basically a graph that the graph would show how often uh, certain levels of the variable occur. So if again you were doing college students, uh, you might a frequency distribution might show the number of first year students, second year students, third year students, fourth year students, and there are other types of tables. So a frequency distribution would just usually be a um, uh, the numbers, the at the bottom would be the at the bottom. As I was stumbling on my words here, I realized it would probably be better if I just showed you. So I found a just a graph. So this is uh so I have up here a thing about frequency distributions. Now this is a um frequency well, let me just pull this up. Yeah, here's a so uh so in this one, this is a frequency distribution of um different majors for college students. So here's the major, and here's the frequency, and notice that it totals down here, and then there's a percentage of it. So that's a basic frequency distribution. uh a relative um, frequency distribution is um, th- actually the one above also had a relative frequency distribution. A frequency distribution usually refers to the number. Relative frequency distribution is the percentages. Sometimes you have them separate. This has them both together. So a relative frequency distribution is uh, it is a percentage. This is a cumulative frequency distribution. Uh, Notice that it the frequency and then percent, and then what it has over here is um, it lists the percentage cumulative. So um, the how do you rate this course? Very good is 22.4%. But then when you add the number of people said very good or good, it's 73.2%. And then when you say the number of people have very good, good, or neutral, it's 96.2%. So cumulative frequency distribution is um, um, you know the running total of the percentage. Now, why would you do with a cumulative frequency distribution? It's usually used. Uh, what you typically would do is like they would do here, like they're doing here. Like you would list it out in order. So clearly, the listing out is from highest to lowest. So you got very good, good, neutral, bad. That's typically what you do with a cumulative frequency distribution, because then what you do is you sort of say, okay, at the very end it's this, and then next is this, so you can sort of start to see uh, you can see the benefit of a cumulative frequency distribution when political surveys will do that. Like they will say uh, the number of people who had a favorable rating of a candidate was 52%. For president, uh, over the past, I guess, decade or so, what's really become big in the news is this idea of favorability rating for a president. And usually, what that means is it would be actually ratings for the president usually follow this scale. You ask them, do you think they're very good, good, okay, bad, and then usually they'd be very bad. And then usually, what the favorability rating is seen as being is a cumulative frequency of these two. So a favorability rating would basically boil down to the number of people who thought the president was doing very good or good. So a cumulative frequency distribution would be those that show either good or very good. In other words, something positive, something above okay or no opinion or neutral. Anything above neutral is seen as favorable, whether it means it's good or very good. Now, what you can see here is these descriptive statistics um, organizing the data actually have a purpose. They describe the sample, but they also they do describe the sample, and you can see that. So when I talk about this idea of using cumulative frequencies for political campaigning, for political polling, you could see the purpose, because when pollsters are getting the opinion of a president, they interview 1,000 people. They're not interested in drawing conclusions just about those 1,000 people. They pick those 1,000 people because those 1,000 people are seen as being a reflection of the population. In fact, they're usually picked for that. They are picked, the geography of where those individuals are located is sort of seen as a uh, sort of a mirror of the population of how the country is spread out. So the idea with it is that you are gathering information about a small group of individuals that are representative of the population. And so, like I said, with cumulative percentage, something like gathering information uh, to talk about favorability, meaning not just the people who said very good or said good, but who said either very good or good, is often why something like a cumulative percentage would be good. Some other way of organizing research is a bar chart. Uh, Sort of the same thing as a frequency distribution above, but a visual representation of it. Pie charts are another one. Um, like I said, pie charts are another one. Um, and so you have a lot of different ones. Okay, so that was uh the bar chart, as I showed you, was one way of representing the data. Here's another one. This one is kind of weird, but I guess I'm going to show it to you. This is called a stem and leaf plot. Sometimes stem and leaf plot is used to represent data. Now it's kind of weird here. Now what this means is basically a stem and leaf plot uh, uh, spreads out the data. This one happened to be ages at a birthday party. So it would be a representation of ages, but rather than have the different age groups, like one way to have done a bar chart with ages would have been to have you, you could have had every age under the, but that gets kind of it becomes hard to represent. If you had every age, uh, because maybe you had one person was 64 and one person was 65, so you have you know like a lot of ones or a lot of small, so it doesn't really give you a clear representation. This is an interesting way to do it, and this is a particularly good um, representative representation of why a stem and leaf plot can be useful. Because if you think about a child, this is a uh, this is a representation of um, the ages at a family birthday party. Now, if you think about a family birthday party, let's say it's for a kid, probably there's a wide range. Grandma shows up, aunts and uncles show up, cousins show up. If it's a big birthday party. So you're going to have a wide range of ages. So a a frequency count and a bar chart may not help you to really get a picture of how the different ages are spread out, because there are going to be a lot of ones and twos. There might be um 60 to there might be like one person each of 57, 59, 61, 63. There might be a lot of ones and a lot of the different ages. Or you could do a bar. So the bar chart, the same thing. It's not going to look very good because you're going to have um a lot of ones in terms of the free ones and twos. So there's just going to be these tiny bars across your across the graph. um you could do the age range. Um, like you could say, okay, here's a bar chart of how many people were there in their 50s and of their 60s, and that might be useful. But it might not really. You might want to know um, how many people are um, 65 and how many people are 68. Um, for a variety of different reasons. A lot of uh, retirement age is still seen as 65. So you may want to take a quick glance to get a sense of how many people were of retirement age or over. Well, that would be if you had a bar chart that told you how many people are in the 60s, that's not going to help you because you might want to know how many people were over 65. So here's the way a stem and leaf plot works is it basically splits the results into two. So it works particularly well for things like ages, where almost all the, if you consider that if someone is 1 or 2 years old, you put a zero in front of their number, um, you're going to cover every age up till 99. Um, and even if you had 99, it would still be, I mean, if you had people in their hundreds, it would still be the same, except instead of there just being one digit here, it'd be two, so it'd be 10. But then what you do is you split um, the uh, the data up. So the ages here would be split up on this side so that the numbers that are in the tens would be over here. And then the one section of the ages would be over here. And you get a quick glance. It gives you a really good way of telling how it's almost like a mixture of a bar graph um, and uh, a frequency count combined, you know, because just by looking, you can just glance at it and see how many people were in their 50s. And you can see, take the example, you can see right away how many people were in their 60s. Two people were in their 60s. You can also, at a quick glance, see how many people were of retirement age, meaning over 65. One, 66. There was only one person who was 66 years over 65. So you you get the benefit of a bar graph because this actually kind of represents the bar. This represents the bar of how many people are in their 20s, how many people are in their 30s, while at the same time also giving you a frequency count. You can get a quick look of how many people were in their 30s, also how many people were 31. 31. So three people were 31. So we know, and again, just to make the point one different way, we know, for instance, that there were nine people who were in their 30s. Here's the nine people in their 30s, while at the same time also being able to say quickly that we know there were three people who were 31. So that's pretty helpful. I mean, stem and leaf plots aren't used a lot. I can't remember the last time I ever used one, but when they are used, they can be quite helpful. Like I said, because they give you both a uh, because they give you a measure of both uh, the like a bar graph, and they give you a measure of um, and they give you a measure like a bar graph while also giving you a separate frequency count within the bar graph. Okay, so getting back to, so I'm gonna stop sharing this screen, and what I want to go through next, and you probably have learned this already, but just as a review, the second type is descriptive statistic. Would be the summary data, would be statistics that summarize the data. And those are usually seen as uh, measures of averages. So the three types of averages and measures of variation. So the three types of averages, which you may already know, but I'm going to go, is the mean, the median, and the mode. The mean, you add it all up, you add up um, the total of what you have, and you divide it by the number of items that you have. So the mean is uh, the mean. Uh, so uh, if you had um, the uh, the total number of averages, the total results that you have, you would add them up and divide them by the number of items that you have. So if you have, if you want to get the mean average weight of somebody, you would the mean average weight of somebody, you would add up of 10 people, you would get the weight of each individual, you would add up those weights and you would divide it by 10 total. That's how you get average. Now, what you may already know or is that's the way most people define mean. That's the most. That's actually the term when most people use the word average. That's what they're usually referring to. Average being you added them all up and divide them by the number of uh, data points that you had. Now, the biggest limitation of mean averages, it's affected strongly by outliers. Um, Years ago, one of my first full time jobs, there used to be we would make the joke that there were four people in the office, um, and we the joke was if there were five of us and one of us was Bill Gates, the mean average income would be 25,060,000 dollars. Now, of course, that's the outlier there because of the four. Um, you know, the 60,000 comes as sort of the average of the four. The 25 billion comes from the Bill Gates part. So, if it, I shouldn't say 25, that'd be the total. So the average income, if the five of us were there and one of them was Bill Gates, the average income would be $4 billion. Um, like I said, that of course is not accurate. It's probably you've got like four people who are earning between 60 and 160,000 a year, and then one person who makes like 25 billion a year. He's the outlier. Bill Gates is the outlier. So means can be strongly affected by outliers, and that can make them not really representative. Uh, Median is another way of doing it, and the median is the exact middle uh, of uh, your data. So what you do is um, you list um, the data that you have. You list them in order, and basically the median is the exact 50% mark, where half of it is above and half of it is below. Um, and um, Now, if it's an even number of items, you would take the average of the two middle. So, if you had like 12, if you had 13 students, then the um, the seventh student would be your yeah. If you had 13 students, then the median would be your uh, seventh student, because if your seven, it would be whatever score the seventh highest student scored. That would be your median, because that would mean that if there were 13, that would mean the seventh, six people would have scores higher than that student, and six students would have scores lower. So the seventh student, either the seventh highest or the seventh lowest, whichever direction you're going, that student, that would be the median score. If you had an average number, I mean an even number of students, then you would take the you would average out uh, the the sixth student and the seventh student, because um, that would be, because you would want the middle point between the sixth student and the seventh student, because that would mean at that point you would have six students above and six students below. So that's the median. This median is the exact middle of so 50. It's where you have 50 above and 50 below. Uh, and then uh, the mode is another average, and that is the most frequently occurring data point. So it'd be the one that occurs the most often. And if there are two if there are two points that occur the most often, then that would be then there would be two modes. And sometimes if every score only occurs once, then you have a mode that's everything. Um, um, so the mode is the most frequently occurring uh, data point. Okay. And then what you have next are measures of variation. But that's going to take a little bit. So why don't we pick that up at the next class? So I will look forward to seeing you all on Thursday.